Hello, Science 20s. Our lesson today is on hydrocarbon reactions. We're going to look at three different reaction types. We're going to look at the combustion of hydrocarbons. We're going to look at the hydrogenation of alkenes, as well as we are going to look at polymerization. We have already looked at catalytic cracking. If you need a review on that, please go back to the previous video on petrochemicals. Now, when we look here at hydrocarbons, I want us to remember that we've actually looked at hydrocarbons before when we were teaching about balancing chemical reactions. When we use the word combustion, combustion is the burning of a hydrocarbon. Remember, in order for something to burn, it must contain oxygen. We're going to do some easier examples because everything we're going to burn is a hydrocarbon, meaning it only contains carbon and hydrogen. Therefore, every time we burn, and we can look at the equation, carbon, we are always going to make CO2. And every time we burn hydrogen, we are always going to make water vapor. So our products will always be the same in combustion of hydrocarbons because when you burn a hydrocarbon, we will always be producing carbon dioxide and water vapor. Now, when we go to balance this, I want to remind you that we always balance carbon first, then we balance hydrogen second, and last but not least, we balance oxygen. If we run across an odd even problem when balancing oxygen, stop, double every previous balancing number, and start the example over again. So following these rules, let's look at the first example. We are going to burn methane. So the first thing we're going to balance is carbon. So I'm going to grab a pen here. So one carbon on the left, one carbon on the right, carbon is balanced. 4 hydrogens on the left, 2 hydrogens on the right, which means I'm going to need 2 H2Os, 4 hydrogens, 4 hydrogens. If I take a look over here underneath water, I have 2 oxygens. For carbon dioxide, I also have 2 oxygens. Therefore, on the right, I have 4 oxygens. On the left, I only have 2, so I'm going to put a 2 here. And again, we check our work. 1 carbon, 1 carbon. 4 hydrogens, 4 hydrogens. 2 oxygens plus 2 oxygens is 4 oxygens, 4 oxygens. My balancing is 1, 2, 1, 2. Remember, even though I don't put a number here, there is actually a 1 right here and a 1 right here. Okay, let's clear that. And let's do another example. So if it was me, I would pause the video. I would try this example for myself. Unpause the video to check your work. 3 carbons, 1 carbon. I'm going to need a 3. 8 hydrogens, 2 hydrogens. I'm going to need a 4. That means I balance my carbons and my hydrogens. Underneath water, I have 4 oxygens. Underneath carbon dioxide, 3 groups of CO2, so that's going to be 6 oxygens. Therefore, I have a total of 10 oxygens on the right-hand side. To balance that, what times 2 is 10? I'm going to need a 5 here, 10 oxygens on the left-hand side. So 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens, 6 plus 4, 10 oxygens. My balancing is again 1, 5, 3, 4. Okay, let's try a little bit harder example. Can you pause the video, try this one for yourself, please? 2 carbons, 2 carbons. 6 hydrogens. I've got 2, so I'm going to put a 3 here. 6 hydrogens. 3 oxygens. 4 oxygens. That means on the right-hand side, I have 7 oxygens. 2 oxygens, 7. Odd even problem, which means everything that I have pre-balanced. So 2, 3 is now going to get doubled. Instead of the order of 2, 3, we are going to go 4, 6, double it. So let's start again. 2 carbons, 4 carbons. I'm going to have to put a 2 here. 12 hydrogens, 12 hydrogens. 6 oxygens, 8 oxygens, and 8 plus 6 is 14 oxygens on the right. 2 times 7 is 14, so the balancing is 2746. Our first type of reactions are now finished. So, reaction number 1, combustion of hydrocarbons. Reaction number 2 is hydrogenation reactions. Hydrogenation has the word hydrogen in it. This is adding hydrogen to regenerate this reaction. We are going to go from an unsaturated double triple bond alkene to something that is saturated, an alkane. Now, the easiest way to do this is I like my reactions to look different. So when I say something's a hydrogenation reaction, I'm going to have my hydrogen come over here and attack the multiple bond. You will see that when that happens, my double bond was here. Well, one of my bonds of the double bond, it's going to break and the drawbridge is going to come down and we're going to attach one hydrogen that I attacked it with on one side and one hydrogen that I attacked it with on the other side. And so when my hydrogen attacks the multiple bond, the bonds are going to come down. One come down to the left, one come down to the right. And when it comes down, a hydrogen can join each of these sides. So we are changing butene into butane. We use this when we're going from something unsaturated to saturated, or when I'm going from a double bond to a single bond. Now, it is possible for this to be a little bit harder. So again, we can add 2 hydrogen molecules when there's a triple bond. So propene, C3H4, I'm going to draw it for you. 1, 2, 3 carbons. It's an ine, propine, so it's going to have a triple bond. This carbon's already made 3 bonds, so it has 1 hydrogen. This carbon's made 4 bonds, it gets no hydrogen. And this carbon over here has made 1 bond, so he's going to get 3 hydrogens. Again, I'm going to draw hydrogen. Hydrogen's diatomic on my periodic table. It shows me that. So when I see hydrogen attacking a multiple bond, we will call this hydrogenation. And what happens is I always like to start by going, draw the same picture that we just had. Now, when it attacks the triple bond, one of those bonds is going to break. And so my triple bond is going to turn into a double bond. And what happens is when that bond breaks, because the hydrogen's hitting it, one's going to swing down, the other one's going to swing down, and these are spots for hydrogens. So on either side of where the triple bond was, we're going to attach a hydrogen. So we are adding, hydrogenating this alkyne molecule. Now, propene is the same molecule we have over here, so I'm just going to redraw it. And again, we're going to add more hydrogen to this. And hydrogen always attacks the multiple bond. So I'm still going to have 3 carbons in a row. These guys are still bonded to what they were previously. The difference, though, is when the hydrogen attacks a double bond, this bond is going to break. And again, we're going to deposit an H on both sides of that double bond. So in the first one, when it attacked, the bottom one swung open and we put a hydrogen on both sides of the double bond. This time when the hydrogen attacks, this time it's going to swing up, and where the double bond is right here, we're going to swing up and put 2 hydrogens. This is called hydrogenation. When we're adding to a double bond, we add 1 set of hydrogens. When we're adding to a triple bond, propyne, we're going to add 2 sets of hydrogen to get it to saturated. The reason we do this is to make the molecule saturated. Now, when is this important? Why do we care about hydrogenation? Well, hydrogenation reactions are one of those reactions where you have this in your cupboard, so industry has already done this for you. So when I take a less expensive oil, a cheaper vegetable oil, right? If we see this unsaturated fats, the reason it's unsaturated is because there's a double bond between two carbons. This is an alkene. Well, if I was to come along here and I was to add to this alkene, oh, didn't have my pen chosen. If I was to add hydrogen and have it attack the double bond, this bond would swing open and I could go from unsaturated to saturated, and I could take a less expensive vegetable oil and turn it into a spreadable fat, right? We're going from oil to butter, ideally, if we want to look at it in its simplest form, by just going through hydrogenation, breaking one double bond by adding hydrogen. Now, our third and final type of reaction is called polymerization. Poly meaning multiple. So, polymerization is when we take a short hydrocarbon molecule and we join it to form a very long hydrocarbon chain. So this is when we turn ethene, something small, into polyethene. Poly, more than one ethene, greater, like polygon, a three-sided shape, and anything larger than that. So triangle up, where mono is small. So if I take a look here, if I add ethene plus another ethene plus another ethene, notice one of these pieces we are going to call a monomer singular. When we add a pile of these singular monomers together, you'll notice what happens. And ideally, the middle part's confusing, so we'll jump from here to the end. If I push these two together, in order for these two carbons to join, they have to make a bond, which means they're going to break the double bond. The double bond now turns into a single bond between these. So this double bond is broken, this double bond is broken, and a bond is formed here. Well, you'll notice that's what you see over here. Here is the same set you had as a monomer, except notice double bond is gone. It had to break the double bond in order to join with a neighbor. Therefore, when we go from ethene to polyethene, all we're really doing is connecting all these monomers together, but losing the double bond. Let's look at another one. We're going to look at 4 of these. So I have propene. And again, here is my propene monomer, CH2, CH, CH3. So we have this CH3 group bonded this time. Again, if I push them all together, we break this double bond in order to make a bond with its neighbor. So again, I'm going to show you a piece of this. This monomer inside the polymer is our starting point. The difference is it had to break a double bond so it could bond to the left and break the double bond so it could bond to the right. So again, this piece is my monomer. This is my propene monomer. And this whole thing would be called my polymer. And we're going from propene monomers to polypropene, more than one propene. Let's do another one. So here we have PVC, so we have the plastic piping. Again, we can see this time double bond, but this time 2 hydrogens, but 1 chlorine. This again is my monomer. And we can find this bonded in here inside this long chain, which we would call a polymer. This long chain, we find the HHHCl, but notice the double bond is gone. Same reason as before. Last but not least, let's look at Teflon. Teflon's a little bit more confusing. Again, it's F, 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 double bond. When these guys bond together, they're going to break the bonds in a monomer from double so that they can swing around and bond in a polymer. And again, here is your section. 2Fs per C, 2Fs per double bond has turned into a single bond. So we are breaking double into singles into making a long chain. That is our final chemistry lesson. I hope this made it somewhat clear.